Our next speaker is our co-chair, Mr. Thomas Green, who will deliver his presentation entitled Much Ado About Net Zero, Lessons Learned on the Path to Net Zero Energy Sustainable Housing. Thomas has over 20 years of experience in housing design, renovation, research, and education, focusing on housing innovation that is healthy, accessible, and doesn't cost the earth. Key areas of work include healthy, accessible, and adaptable housing, passive solar design, building-related environmental impacts, and sustainable housing. Thomas designed and managed several key research and deployment initiatives, including the CMHC Open House Barrier-Free Demonstration Home, healthy housing exhibits for the Montreal Science Centre and Korean World Fair, and the Equilibrium Sustainable Housing Demonstration Initiative. Thomas's presentation will cover lessons learned, challenges faced, and opportunities realized through the CMHC Equilibrium Sustainable Housing Demonstration Initiative and next-generation low-energy housing projects. These insights result from the design and delivery of a diverse collection of new and retrofit low-energy sustainable housing projects located in diverse regional markets and climates across the country, providing critical information to achieve the desired outcomes from the next generation of sustainable housing in Canada. Please join me in welcoming Thomas.
Thanks so much, Chris, and good morning again, everyone. So it's a great pleasure to be here today to be able to talk to you about lessons learned on the path to net zero energy sustainable housing. It's been a journey of 8 years in the making and much, much longer if you consider all the other energy performance initiatives that we've done in Canada over the last 20, 25 years. And certainly now is an exciting time because we've got a lot of new developments in the area of affordable and low-energy sustainable homes. So given the focus of the NHRC this year on outcomes, my presentation is going to talk about low-energy sustainable housing solutions built on a solid foundation of research, of an informed design and construction process, and using post-occupancy evaluation to try and ensure that we get the results that we envision. So when we started this journey, we didn't have a lot of outputs at the time or outcomes, but we did have a lot of questions, such as, are consumers interested in low-energy sustainable housing solutions? Is our design and building industry ready? Is it doable in Canada? Will it really work? Will people like it if we can do it? And of course, is it affordable? And are they repeatable solutions? So those are all key questions that we started with. Now, any discussion on energy efficiency or energy efficiency improvements in buildings invariably ends up with one simple question: what is the payback? And while that is an important measure or a metric to consider, the current discussion on energy efficiency is looking at a multiple benefits approach and is revealing a broad range of potential positive impacts that come from improved buildings, building quality, building performance, and some of that we touched on yesterday in our discussions. Taking a quick snapshot of where we are with respect to energy efficiency in the Canadian residential sector, between 1990 and 2010, the residential sector energy use in Canada increased by 6%. So we're going the wrong direction for our team that's heading off to Paris for the COP conference. And there's a number of reasons for that. And actually, our energy increased by 6%, despite the fact that the actual performance of buildings, the average performance of buildings, actually improved by 21%. Okay, so buildings themselves are more efficient these days on average, but we still have an overall increase in energy consumption in our country from the residential sector. Now, the reasons for that, of course, population increase is one of the reasons, and other are consumer trends. Canadians have bigger homes right now, and there's actually fewer people living within them. And low-income households typically face the greatest energy burden and risk due to risk to health and safety, usually due to substandard housing conditions. And energy expenditures have a big impact on housing affordability. Low-income families can spend more than 17% of their incomes in household energy, where other households spend on average just 4%. So how can a program of research help inform achieving better outcomes for energy performance and housing-related impacts. So a case study here I'm going to use is the Equilibrium Housing Initiative. It's a national design-build demonstration initiative of market energy sustainable housing. That means that these projects are prototypes, but it's all using readily available technologies and solutions on the marketplace. And the focus was on design and construction of healthy, low-energy, resource-efficient housing as affordably as possible. These had to be sold on the market so the builder could earn his next meals. And on performance, the teams were requested to target near to net zero energy performance and low housing-related environmental impacts to land, water, and air. And the initiative itself is a lot to do with education through research, associated research projects related to the demonstration homes, the demonstration phase itself to raise awareness, and through performance monitoring and reporting of the results we learned from this. So the approach we used was essentially to focus on builder-led interdisciplinary teams, and it was an industry-government collaboration as far as delivering the initiative. All the teams had to undergo design charrette workshops, which is an intensive 1 to 3 day sort of period of really working on the vision, the goals, and the tactics to make their designs and achieve their design goals. All the teams had opened their projects for 6-month demonstration period. Projects had to undergo 12 months performance monitoring with occupants. And of course, there's a lot of related publications, reports at conferences and things, and we had 3 technical forums across the country, again, to share the experiences gained and the lessons learned. So just to make sure we all have a common definition of what we mean on the project, Equilibrium itself represents a vision for balance between between the demands of our built environment within the capacity of our natural environment. And essentially, the initiative was structured around 5 key performance principles, being health, energy, resources, environment, and affordability. And nestled within that are 27 sustainability indicators. So it's a very broad and holistic approach to sustainable housing. Energy is one parameter, but indoor environmental quality and resource consumption issues are also included in that. So, as I indicated in the beginning, we started off with a lot of questions on this initiative that needed to be answered as we evolved towards more sustainable models of housing. So are consumers interested? Well, when we started the initiative first off, we did some market research. We went out and did focus groups with consumers. And we got some interesting comments and some questions from them. First of all, they said, well, that sounds great. We essentially described this model of sustainable housing, and they said, that sounds great, but maybe it sounds a little too good to be true. And then he had other questions. Well, what would it look like? Will I still be able to live downtown? Because they thought maybe a green, sustainable home had to be out in a green field somewhere, and they liked the urban living. That was people in Montreal. Right? And will it really work? And, of course, what will it actually cost? And since that time as well, there continues to be more market research and information available on green building trends, green housing. And CAGBC in 2014 did a report on green building trends, and over half of the respondents reported that a third of their projects they build are currently green. And they're predicting that by 2017, 70% of the respondents expect to be doing 30% of their projects green construction, and half of them will be doing a majority of their projects as green. So there's a trend there towards more and more green building. In 2015, the CHBA did a home buyer preference study of the top 10 must-have features for home buyers. And 3 of the top 4 must-have features were all about energy efficiency. And for anybody that's really curious about what the number 1 feature is, any guesses? No. Low cost, maybe, yeah, sure. Walk-in closets, okay? As long as they were efficient, right? Okay. So, the key question we had in the beginning, is our design and building industry ready to deliver on these high-performance housing projects? Well, we just started off with some industry interviews with key players, builders, developers, And they identified key features they thought would be important. Energy efficiency, of course, but combined with healthy housing attributes. They thought that those two elements combined would make a much more saleable product and have much better impact. Now, they identified important features that had to be addressed, such as quality of construction, cost, of course, making sure you achieve your performance, inclusion of green features, recognition of green features, and third-party certification. And they also identified a series of barriers to the successful implementation or deployment of low-energy sustainable housing, including upfront cost, risk complexity, risk related to the complexity of the build or design, performance and durability, and regulations, inspection practices, and appraisals. And those industries are maybe not quite ready or familiar with more advanced forms of design and construction. And since the time we launched Equilibrium a number of years ago, there's more and more building performance initiatives out there available. Earlier on, we had R2000, Energy Star, and Built Green programs in the country. And in 2009, the Lead for Homes initiative from the Canada Green Building Council was launched. And we're seeing more and more projects starting to strive for the Passive House, the European Passive House standard levels of performance. And more currently, Natural Resources Canada has launched an R2000 Net Zero Energy pilot project, as well as there's an ongoing Eco-Energy Innovation Initiative where 5 production builders are each building 5 net zero homes each across the country. And the CHBA has recently initiated a Net Zero Energy Housing Council, where they're going to look at home labeling program for net zero energy homes, brand marketing communications, education initiatives, and financing mechanisms in support of zero energy homes. So, sounds like a good idea, and we got a lot of interest. Is it really doable in Canada? So, the first step we did in Equilibrium was to launch a national competitive process, really to test the waters and interest. And we got a lot of interest. 630 people or companies responded with expressions of interest. Ultimately, through evaluations by independent committees, we had 15 teams selected and 11 projects built, realizing 16 housing units. And the projects are spread out all across the Canada, west to east, in a range of regional markets and climatic conditions. And what's really interesting as well is the variety of projects that we have. We have single-family detached, semi-detached, 3-unit condominium units. They're built in rural, suburban, and even some tough urban site locations. And we have homes that we have a renovation of a 1946 wartime house, and we have an affordable housing project as well. So we have a lot of different projects and styles represented. So, will it all work is a key question once you get that far. And in order to understand that better, we come to the performance monitoring stage of the Equilibrium Initiative. And essentially, we want to know what is the energy consumption for the main energy performance measures in the home, what is the renewable energy generation, and what is the, it also involved air tightness testing, and thermal comfort evaluations and indoor environmental quality testing. So we want to know how this actually works in the field with real occupants. As well, Christian talked a lot about performance monitoring. It's really important early on in the stage to try and help you strive to meet your performance targets. All the projects in the initiative used Hot 2000 and Red Screen to do performance modeling of their projects prior on to help guide them towards their performance goals. And you can see all the projects, the Equilibrium projects there in red that have very high EnerGuide rating system scores ranging from a score of 94 from the Now House, the retrofit project, up to 100. And 100 would represent a net zero energy home. And this is a home that produces as much energy as it needs or consumes on an annual basis. So how did they get, or what did they do to sort of achieve that kind of high level of performance in the models? Well, first off, they had a really high performance building envelope, lots of insulation under the slab, all in the walls, the basement, the upper walls, the roof. Some of the projects even have insulation levels in the attic, for example, of R100, and that's about 2 feet of blown-in cellulose insulation. And you can see there's a range there in how the teams approach this, bouncing off their insulation, but they're much higher levels than you would normally find, obviously. Other key attribute they have is very airtight construction. All the projects ranged in their measured airtightness values from below 1.5, which is the R2000 standard, and a few of the projects even come in lower than the Passive House standard of 0.6 air changes per hour. And the retrofit project there is the Now House. You can see being a retrofit, we're able to measure the air tightness before and after the retrofit, so it improved from 5.6 air changes per hour to 2.6. And another really interesting outcome is getting out there and doing these projects is there was a whole range of approaches used in order to achieve these levels of performance, from spray foam insulation to vacuum insulated panels, structural insulated panels or SIPs. We had double frame stud walls built on site, and we had modular walls built in a workshop, and ICF insulated concrete formwork was used in some projects, and we even had a modular project that was built in a factory and assembled on site in one day. So lots of different solutions. But one thing they all had in common was a really strong focus on energy efficiency and energy conservation. Again, through the building envelope performance features, as well as through the interior fit-up with energy efficient appliances, lighting, LED lights, low energy mechanical systems, and some teams even tried to reduce the amount of energy lost through phantom loads with all-off switches and things. All the teams paid quite a bit of attention to optimizing the benefits of passive solar design, gaining lots of good natural daylighting in the homes, as well as capturing solar heat when you want it and shading out any heat gains when you don't want them. And all the systems, of course, integrated renewable energy systems so they can try and strive towards the net zero energy goal. And used a lot of different technologies for photovoltaic systems and solar thermal systems. They were the majority of ones. And you can see lots of different technologies and applications done in the project. So quite a range, again, of solutions. And as a final step, they all tried to steal back some of the heat that's usually lost in a home through heat recovery from the ventilation system, as well as drain water heat recovery. That's the image on your right. So this is just a table of all the systems, renewable energy systems and heat recovery that were used in the projects. And the thing to note here is that all the teams paid careful attention to passive solar features. They all have heat recovery ventilators, and they all have photovoltaics in order to produce energy. And this is how they move towards the net zero energy targets. So how did they actually perform once they're measured? So in this graph here, there's a lot of information on tables and graphs, so you can use the presentation as a reference document after as well. But the red lines here in this graph are the energy consumption values for the equilibrium projects compared to conventional newly built houses for about the same time period. You can see there's a fair amount of variation between the performance of the projects, and that had to do with where they are and the design goals of the teams themselves. But overall, the equilibrium projects use a lot less energy than the standard builds. The green lines there are the renewable energy generation. In this case, it's a combination of the photovoltaics and other renewable systems, such as solar thermal. And the blue is the net energy balance, and that's really the consumption plus the renewable energy generation. That's the difference. So looking at how energy is used in a typical Canadian housing, we can see that the largest consumption component comes from space heating at 65%. This has been pretty typical and hasn't moved that much over a period of time. And the other two key areas are domestic hot water and appliance lighting and plug loads. But when you look at a low energy sustainable house, in this case we're looking at the Avalon Discovery 3 project, we can see that the pie chart now is starting to change quite significantly. The largest energy load in the home now comes from the appliance, lighting, and plug load category. And what's key here is that occupant behavior has a huge role to play in that measure. And Space heating has been significantly dropped, and domestic hot water heating has been reduced as well. Now, the big white square there, that's just less than, a bit less than 50%, is the energy you don't have to supply or buy in the home because of the high performance design features. And Avalon wasn't even one of the lowest energy consuming projects in the sense. There were some that even doubled the energy savings on this. So this is essentially the same information now put into a bar graph, and where you can see each of the projects, each of the equilibrium housing projects. And so once again, for the majority of projects, the appliances and lighting category in purple there is the largest single category for the majority of projects here, because the building envelope and has now really reduced the heating load demands. And the Harmony House project there in gray is just because we only had the total energy outputs. We didn't have it broken down by different end use. And some people like to look at energy intensity, which is the amount of energy used per meter squared per year. So this is a similar graph looking at the 11 projects. And again, you can see that the appliance and lighting area is one of the largest loads in homes. Looking at measured renewable energy production, the largest contributor to the renewable energy side will certainly come from the solar electric or the PV panel systems, with some contribution from the solar thermal system and a ground source heat pump in one project. And the anomaly there for people that are noticing it right away is on the Now House, the retrofit project. You can see that the solar thermal system actually caused an energy penalty. During the time of monitoring, it just was not performing optimally or performing well at all, and so it actually was actually costing money to run that system. Of course, it's not just about energy, although we spend a lot of time on energy. These projects had to meet the 27 sustainability indicators, a broad range of sustainability features. We looked at measured potable water consumption for these projects, and all the new build projects show significant reductions in potable water consumption compared to the Canadian average of 251 liters per day per person. And the Now House retrofit project did improve its energy consumption or reduce its energy consumption prior from being measured prior and post retrofit, but it's still a bit higher than the Canadian average due to the lifestyle choices of that occupant. So the first presentation, we talked a lot about modeling to achieve higher performance, and all these projects, as I mentioned, were modeled. And so here's a comparison of the predicted versus measured energy consumption of all the different projects. And in the majority of cases here, the measured energy consumption was actually less than predicted. So for the most part, there were no unpleasant surprises. And looking at the predicted versus measured energy production, in this case, for 9 out of the 11 projects, the measured renewable energy production was actually less than what's modeled. And as Christian said, you're never going to get an exact match, but you want to be within an accurate range, and you want to keep doing calibrations of your model to make sure they reflect as best as possible what can happen in reality. And I think there were a number of reasons for this that we found from site visits and investigations. Certainly in the wintertime, snow loads on some of the panels were a factor. So this one looks at the predicted versus measured net energy. Again, in the blue, this is the consumption plus the production values. And we can see that during the 1 year of performance monitoring, none of the houses actually met a net zero energy housing target, okay? But 2 of the projects are really, really close. The Harmony House just used 171 kilowatt hours per year. This is the net value. And EchoHaven just 341. So very, very low net energy use on these projects. As I mentioned, some of the reasons that the modeling and the modeled and the measured performance maybe don't line up. This is a look at the solar electricity production from Riverdale NetZero. You can see the measured values in the blue bars compared with the model values in the red band. And you can see that for the most part, it follows the curve quite well, except for in the winter months. As I mentioned, snow being stuck on the panels and even some shading from trees and even building features like dormers in the winter with a low sun angle can cause lower performance values from your PV. Similarly, looking at the solar thermal domestic hot water production, this is from the EchoHaven project. The modeled versions are in the red band, and the measured are in the bar graph. And in this case, it was the summer performance that didn't quite match up with the modeled predictions. So after you do all that, and you've got this nice prize at the end that you think is going to work well, and the performance monitoring shows it's doing quite well, will people actually like it? And that's a key question to really to complete the loop on this, come full circle and start looking at some post-occupancy evaluations. So we did some market research with occupants that had lived in these homes for at least a year. And essentially we wanted to know, what is it like to live in a near net zero energy sustainable home, so we can inform our process. So we got lots of good information and feedback. There's a full report available, and I've just pulled out some excerpts from that. Some interesting outcomes include the choice of a sustainable home for the respondents was primarily driven by an interest in the quality of home, of course, but also its location. So the old adage, location, 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 still applies here. It's really important where they are in relation to their daily trips and amenities and services that depend on. So we might have to change it to location, location, low energy, because location is still a key attribute. But of course, location has a lot of links to sustainability, because you could have a net zero energy home, the lowest energy home, possible. And depending on where it's located, it can have a high impact on energy use when you start looking at transportation-related environmental impacts. So all the occupants also reported a heightened concern for reducing their environmental footprint after moving in. What's really interesting here, it's kind of like a reverse boomerang effect, in that sometimes when people start getting LED light bulbs and they think, wow, these things don't use any energy, they just leave them on all the time, right? And then you're wondering, when you look at the performance evaluation after, why would the energy go up? They got really low energy appliances and features. Well, in this case, the people knew they're moving into a low energy house, and they all had energy dashboards to sort of let them know their energy consumption, and that got them really keen and excited on this. And so they actually were looking for further ways to improve their living habits to further reduce their energy consumption, and that was a measurable effect. None of the respondents felt that the cost of building or purchasing their sustainable home was viewed as prohibitive, and they see that really as accruing financial benefits over time. And when they got together with their neighbors, they were kind of shocked at the difference between their energy bills and their neighbors' energy bills. And another element was that they found that sustainable buildings that provide a high level of comfort while using simple technology were strongly endorsed. And so they really preferred moving towards simple ways of achieving low energy and no complex mechanical systems and things. And in the strive to reach or come near to the net zero energy target on this initiative, there was a lot of technology put into these initial sort of first generation net zero energy homes, including solar thermal systems for the space heating. And you can see that the occupants on that sometimes looked at those systems or would wonder, who's going to fix that if something goes wrong. So, but as far as the passive operation of these homes, due to the high quality building envelope, and one respondent, they happened to go through a 24-hour power outage during a time period when they had daytime temperatures of -20 to -10, and the home didn't even drop below 19 degrees during that time period. So they really felt that was a strong endorsement of the solar energy gains and the performance of the building envelope. Living in a sustainable home elicited a high level of satisfaction by all the occupants. They felt like the inside environment was very comfortable and even temperature or wherever they were in the house. Some people even went as far as calling their home a health refuge because they suffered from allergies, asthma, and they felt that much better in their home after they moved in. And quite often we heard the comment that if they were to rebuild or move to another home, they would want a lot of the same features. And to the point where they said they didn't think they could live any other way now. If they moved, they'd have to move into another sustainable home with the same type of quality and features. To many of the respondents, living in a low-energy home was more important than actually living in a home that achieved the net zero energy target. And that's an important distinction there because there's quite a difference in complexity and cost from moving from a low energy to net zero energy. Photovoltaic systems were very popular because they were simple to use and easy to operate. There isn't really much impact on the homeowners. And some people even felt that it was very cool and sexy to be producing your own energy, much more than that, drab old energy efficiency, which is why I keep mentioning energy efficiency first, because it still counts as the most important move, but not as cool, I guess. So to all the people involved here that actually lived in this, to experience their low-energy home was really to believe in it. They all held highly favorable opinions of sustainable housing from their experience. They strongly endorsed living in a sustainable home to their friends and family, and they all expressed a strong desire to seek a similar type of home or construction if they ever had to move. So we got people keen on it, and they like it. Is it affordable to deliver homes like this? So early on, one of the teams is information on the incremental cost curve of going from a standard build to a net zero energy home from the Riverdale NetZero project. So it starts with, on the left-hand side, the base case house. And by continually adding energy conservation measures, which are the interventions above the red line across the table, they continually reduce the actual energy requirements of the home. And to the point where 78%, nearly 80% of the distance of the journey to a net zero energy levels of performance are achieved with 20% of their incremental costs in this example. And to get the remaining 22% of the distance, you have to add the renewable energy systems, and that, in this case, resulted in 80% of the incremental cost loads to the home. So conservation first really is a simple and most effective approach. So looking at the cost profile between the first low-energy sustainable homes and several next generations, on the left there we can see the Riverdale NetZero project. The Equilibrium project had an incremental cost of $110,000 for the unit. And in the very next project that the same team did, they've done quite a few zero-energy, low-energy homes to date. Then the very second generation project, the Mill Creek, they'd already dropped that cost to $67,000, and it continued to drop down in cost. The third generation, Belgravia, was $58,000 incremental cost, and still at the same or higher levels of performance. Now, how they'd achieve that? Essentially, they're gaining experience, and they kept the high-performance building envelope. You can see across the board there. They reduced and then eventually eliminated the solar thermal system and focused just on one renewable energy system and technology in-house, and that's the photovoltaic systems. And the avoided cost there is with the high-performance building envelope, insulation, windows, air sealing, etc., they found that they didn't need a typical heating system, and they're installing really inexpensive baseboard heating systems throughout the house, and so they have some avoided costs and savings there. And what's really exciting is building on the experience of these first homes that we're seeing more and more examples of affordable housing projects and multi-unit residential buildings that are pursuing low-energy housing solutions. And this is just a sample of some from across Canada, and you see the same trend internationally. So is this repeatable in order to get to scale up in the number of sort of low-energy sustainable housing projects in neighborhoods? Oh, I'm just going to go back if I can. The particular example here is the Now House, the retrofit of the 1946 wartime house. And this project alone now has been repeated over 100 times in southern Ontario. The people that first saw this project in the Windsor-Sussex area have a portfolio of these type of homes, and they wanted to really increase their performance and reduce the operating cost to their occupants. And so they did a further case study called the Windsor 5, where they tested a number of solutions to see which was the best bang for the buck, and then they rolled out with 95 other projects right away. And so that's a really good success story on how repeatable this is on the retrofit side. So from the experience and the projects we have done to date, we have sort of an approach fairly clearly outlined, a fairly consistent approach to achieve low-energy sustainable housing through climate-specific integrated design, a lot of emphasis on energy conservation, energy efficiency, using passive solar, heating, cooling, and shading features, and incorporating healthy indoor environments is pretty critical. And also looking at really taking advantage of natural daylighting and reducing resource consumption, water, materials, etc. Now, if you add the renewable energy systems to that, at this point you have a low energy sustainable home. If you want to go towards net zero, you integrate the renewable energy systems. You have a grid interconnect, so you can buy, sell, or exchange energy throughout the year, and that's how you can move towards a net zero energy consumption and very low environmental impact. Now, I think that also from the experience of these projects, we can see a formula for low-energy affordable housing that really starts early on in the design phase. As you saw from Christian's presentation, it's pretty important to really investigate these targets for improved performance and quality of housing right from the beginning. So you have to start with a sustainable housing vision and keep and share design goals, follow an integrated design process. Charrette workshops are great to sort of bring everybody together, build your vision and your targets of solutions, and looking at financing that's going to balance the cost between capital costs and ongoing financial operations costs. Performance modeling is key to really understand the nature of building and see that you're moving towards your performance targets. And then, of course, ensuring quality construction and building commissioning are essential steps to make sure that you're actually building what was designed there in the first place. And finally, to finish the loop, post-occupancy evaluation through performance monitoring can help inform the process, help you calibrate your models, and then getting occupant feedback is really essential. And occupant education, as well as education of people that are doing the operations, maintenance, and repair are essential, again, to assure that you're going to continue to meet your performance targets through time. And what's really exciting these days is that more and more housing projects across the country and internationally are starting to target very low levels of energy consumption. And this is just a quick sampling of projects around Canada. And in the next presentation, Danny Pearl is going to talk about some of these projects in much more detail. So when we started off with a lot of questions on low energy sustainable housing, and I think that from the experience we have in the field, we already can see that the answer is a sort of a resounding yes to all this. We need more practice and more evaluations of this to keep fine-tuning the process, but we've had a huge increase in interest and a capacity building of industry to actually deliver very low energy sustainable housing projects across the industry. And of course, it's really important to share lessons learned. Forums like the NHRC and elsewhere are really important to help other people start with the information and experience that we've all gained through this. The demonstration phase was really a powerful element of the Equilibrium Housing Initiative, for example. All the teams had to have their projects open for a minimum of 6 months to industry and consumer audiences. And some of them had them open longer. The demo period duration is shown in the red bars on the graph. and the blue is the number of visitors. So cumulatively, with all the projects open for their 6 months and more, there's essentially 10 years of exposure to these projects to help raise awareness and increase education of people coming to visit the projects about what's possible these days, what's doable. And the total number of visitors of that was over 70,000. So again, on the information sharing, helping people start off on the right track, there's a lot of resources available on the CMHC website and also available through NHRC website. The Canadian Housing Observer in 2014 did a full chapter on sustainable housing where you get a lot of information on the performance. You don't need, I think we covered a lot of it in the presentation today, but it's another ongoing resource to let people know how to achieve low energy housing and the performance attributes that were successful. So thank you very much.
Thank you, Thomas. If there are any questions? I'll start off with one then while you guys think deep thoughts. When you're looking at the incremental cost, Thomas, did you factor in the thickness of the walls and how much real estate that eats up? I'm curious, thinking in markets like Vancouver where land is very expensive, if you looked at that. Mm-hmm.
I don't think we got into a lot of detail on the thickness versus the space loss type thing, but most teams did look at their incremental costs for that project. But as I say, being a prototype, it's doesn't really represent the next level of projects that came after it, because the cost dropped in half right away, and in some cases even the cost of photovoltaics dropped so much just since the beginning of the initiative to the end that it's really an area where there's a lot of change going on and costs significantly dropping. But I think that the other point about costs again is recognizing this link to ongoing operations. You know what it costs to the cost of housing is not just the first initial capital cost, but you have to factor in the operations over a long extended period of time. And that's why I think we're seeing more and more interest in the social housing, affordable housing sector of really pushing performance to try and manage that sort of long-term financial exposure.
Yeah, it's interesting thinking of the vacuum insulated panel project, which you might think would be very expensive up front, perhaps for that technology, but if you factored in transportation, if you wanted to build in the far north and transport that technology, it might start looking more cost effective in some markets.
Yeah, I think that's true. And I think of all the things in the homes, that was, I mean, it's an off-the-shelf product you can buy, but it is still, quite unique and very expensive. And it was good to put in this project because there's a lot of things you have to think about to be able to protect those panels. So the construction, the wall construction methods are really critical because they're very thin panels with high insulation values. But if they don't perform, you sort of sunk everything into that because now you don't have a lot of other passive insulation in the wall panel. But it was great to get some experience on that. Any other questions?
I'm just curious about the occupants of the homes while it was monitored. Like, was it reflective of what a typical, how did you said there was a draw or something? How did you just decide on the occupants that were going to be living there? And what was the makeup of it?
There was a draw, but that was only for one project. These homes were sold on the market. Some of them might have had an owner prior to the design and construction of it, and they were involved in the process. But all the homes were designed and built on spec and then sold throughout the construction or completion process as typical. But there was a house that was a Dream Home Lottery Prize, the Green Dream Home in Kamloops, BC. And that was kind of interesting because everybody else knew what they're getting in a sense, right? And it might have been driving a Prius or something and have, green streaks in their lifestyle already, and that's why they want this home. But in the lottery prize, of course, everybody thought they were going to own this house for a $100 ticket. And that's the one that if you were wondering why on a 6-month demonstration period we had like 130, or so many people in, it had the highest amount of visitors than anyone else, is because everybody comes out in spring to see the dream home, right? So it's a nice way to get a lot of exposure to your product, that's for sure. But the couple that won, they live downtown in the city, and this is outside of downtown, and they have a child going to school type thing, and it was kind of in a golf resort community almost. So they're thinking, well, this is, great bonus for our life. What we're going to do is we're going to move in there, and we're going to fix up our downtown home, then move back, right? And but after they started living there for a while, they really started to appreciate the comfort and the qualities of this house. And I personally, I wouldn't think it would be ideal for a young family, starting off there. But they decided not to move in the end because of the quality environment there. And there's we have some YouTube videos on our website, and you can hear about that project on that. And they talk about how in November they haven't even turned on their heating system yet. So they were really pleased, largely with the low energy consumption, but also the quality of living environment. So that was kind of an interesting test of people that didn't necessarily choose to live in that sustainable home.
Other questions?
Yeah, I had a question regarding some of the technology that was put in, and if there were any challenges with the homeowners operating. I saw the ground source heat pump on one project, but also even as simple as heat recovery ventilators, which several years ago necessarily weren't codified or that common. Did you see any challenges with homeowners operating that new technology?
Mm-hmm. I think it's a good question, and one that you have to keep raising and paying attention to. And I think there were issues with the technology in some systems. As I said, these projects were striving for near and net zero energy performance, so they threw a lot of stuff at it. And but given that, we really were able to see what works well, where the challenges are, and especially in relation to occupants and how they use and interact with their home. So for the most part, all the passive elements, the building envelope, that works fine. HRVs, I don't know of any issues that came up with that. And PV panels were kind of simple and unobtrusive for anybody there. They could see on their energy meters what they're making, and some people had really good deals with feed-in tariffs, and so they would get financial payback from these systems. But I think the system that did cause problems in some cases certainly was the solar thermal systems, and largely when they were trying to supply heat for space heating, as opposed to a solar thermal system that's just supplying domestic hot water. And that's because they weren't really designed for that. It's not really a out-of-the-box solution. And there were a lot of controls and measures and even backup systems installed. So after the initial projects like that, in the industry, you can see a trend really towards simplification, not using solar thermal for space heating, using it for solar domestic hot water, but you're not sizing it for winter loads anymore. You give up and you purchase top-up energy in the winter, because with the solar thermal system, you don't want to get into a situation where in the summer you're overproducing and you can't store it anywhere. It's just lost. PV panels, on the other hand, if you overproduce, you can get a credit or sell the energy to the utility. So that way, that's another reason why some teams in their next generation projects really move towards one renewable energy system, that being the photovoltaics, just to simplify the amount of technology in the home.
Any further questions?
Hi, it's Malcolm Mayfield from CMHC. Thomas, every time I've heard you speak about equilibrium a number of times, and every time you do, I get excited all over again, so I really appreciate this. My question is about what stage of adoption this is at. And you'd mentioned that a number of new projects that have come online, and this has been an effective way to kind of communicate these technologies to, I mean, I guess both consumers, but I guess I'm thinking more about developers and builders. And do you think that Equilibrium in its current format would it be useful to push a little bit further to kind of get more developers and builders to adopt these sorts of things, or would you go about it a slightly different way, knowing that you've kind of moved, or that this has kind of we've moved down the field a little bit? I guess, how do we take that next step, or do you have any thoughts on how we take that next step?
Yeah, I think that the initiative sort of was the proving ground for this approach. And as I said, that we had a broad range of solutions, typologies, and things. So I think that it's possible, it's doable, the interest is there, and moving it to the next level. I think what's really interesting is to see the frontier that's opening really is in affordable housing projects and in multi-unit residential buildings, because we've got a lot of experience now on low-rise, single-family, and we're seeing more and more initiatives in the industry and more interest in consumers, and it's pushing it along. But I think a good next frontier is really to focus on MURBs, affordable housing stock, and it's great to see it already. People that are developing in that area, without a lot of help, they're really pursuing these really low energy housing solutions, even targeting passive house levels of performance. And the reason why is that they have a much longer term view. When you're going to own a portfolio of units, whether it's MURBs or singles or something, and you have a client base, low income client base type thing, you really have to manage your expenditures over time and your financial risks. And so that client group has a very long term view, and they don't mind, in a sense, investing more in the building upfront in order to get that sort of security and lower operating costs over time. Okay? And that's really important, to have that kind of long-term view. If you're just doing a building to flip and get the highest profit, you don't have sort of the incentive to gain there. So I think that helping support that industry more would be a key area of work right now. And then it's just using shame tactics on the rest of the people. If they can do it, there's no excuse for anyone else, really.
Chris? Just a follow-up to that. Malcolm, the whole point of the Equilibrium initiative was a demonstration to prove concept and show that it could be done. And there's a number of industry initiatives taking off now. The CHBA, for example, their NetZero Energy Home Coalition, is that right, or committee, has a standard out, and so in other words, industry has grasped this, and they're running with it. And there's a time for government to be involved, to kick things along and invest some time and effort. And this is a really good example where industry looked at something that's happened over time and the research that was done in Canada and elsewhere, and it's made its decisions. And now we're seeing a commercialization of the effort through the efforts at NRCan in partnership with CHBA and other stakeholders to make this a commercially viable mass appeal product. I don't know if you want to speak to that at all, given your connection to CHBA.
Yeah, I was just going to say that we've used the outcomes from this project in designing our NetZero program, and that program is for the mass market. And there's some really important work that came out of this. Focus on the envelope, focus on simplicity, and off-the-market products, or off-the-shelf products. So. Good. Thank you.
Okay, you're welcome.